So now our step number 1 is to create all the directories. Okay, all directories. Step number 2 is to create a P file. P file is the init.ora file, init.sid.ora file. And now step number 3 is actually to create a database. We are now going to execute a command called as create database, and we are going to do it. So how do we do it now? Create database. So first thing is, obviously, on the Unix machine, export Oracle SID is equal to focus1. So this is the name of your Oracle instance. Okay, now I want to kind of start differentiating between the instance and the database now. Whatever we wrote inside that init.ora file, that was the name of the database. Whatever are the data files in my diagram there, this is the name of the instance. Usually the name of the instance and the name of the database are going to be exactly the same. There are some rare situations where the name of the databases and name of the instances are going to be different, and that is in Oracle RAC environment. So we'll not talk about that. But yes, in all of our discussion that we're going to have here, the name of the database and the name of the instance is going to be the same. So many times I would say SID is the name of the database also, but in reality it is the name of the instance. Okay, so you are going to write this at the Unix prompt, export Oracle SID is equal to focus1. Then at the Unix prompt you are going to type the command SQL plus in single quote or double quote slash as sysdba or slash as sysdba. What is this command going to do? Usually you have seen SQL plus command will allow you to log into an Oracle instance, Oracle database, whatever you want to call it now. And then it will create a dedicated server process for you, and it will now do the parsing and all that stuff. But there is no database right now. So what are you logging into? You are still logging into an Oracle instance which has not yet been started at all. Nothing is running. There will be just one dedicated server process for you which will be running now. Okay, and this is a special way of logging into the database instance called as a sysdba. We have seen in the our user security discussion that there is a user whose name is sys, and if you want to log in as user sys, you must type the command like this, and that user is the only one who can execute certain privileged commands, and those are create database, drop database, startup database, and shut down database. These are the 4 commands at least, and along with so many other commands, those are executed only by that user sys. And to log in as that user sys, you have to type something like this. Now nobody has asked you the password here, and can anybody do this thing? The answer to that is no. If your Unix user ID, I'm assuming that you are logged in as Oracle user. I'm assuming this is a major assumption. I'm assuming that you are logged in as a user, Unix user Oracle. This is a Unix user whose name is Oracle. Now when we do the Oracle software installation, we will see that a little later, this Unix user Oracle is created, and he has been granted a certain group, and the name of the group is DBA. Just like in Oracle we have the roles which are granted to certain users, in Unix we have a group that is granted to a user. So this DBA group is a very important group, and you can actually fire a command, Unix command called as ID. ID is a Unix command which will tell you what groups you belong to, and you must see there a DBA. If you don't see a DBA there, then this command will fail. Let me say this again. If the Unix user Oracle is not a member of the DBA group, then this Unix command will fail. It is one of the requirements to log in as a sysdba. It is one of the requirements to log in as a sysdba. So now you are logged in as sysdba, that means you are logged in as user sys, and now you are inside SQL plus. The database is still not running. Now here you are going to type the command to start up the Oracle instance. You are going to start up the Oracle instance, so you are going to type the command startup. But now you are going to just say startup and no mount. I will come to this word no mount, it requires a lot of discussion. Startup no mount P file, on the same line, P file is equal to, and in single quotes you are going to give the name of your P file that you have created. Your P file name is what? U01 app Oracle and init focus 1.ora ORA. So this is what you are going to write in single quotes. So what is happening at this time? We are telling Oracle that please start up an Oracle instance based on the parameters that I have written in this file. So when the instance is started, what would be the size of the SGA of that instance? Whatever is written in this file. What would be the undo table space that we will be creating little later? That will be something else. Now the instance knows what is the name of the control file. At this time it is very important to understand that instance now knows the name of the control file. And instance is just started in a state, in a phase called as a no mount phase. What is the meaning of a no mount phase? The meaning of a no mount phase means you don't have anything other than the P file with you. If you have, so here is the P file. If you have the P file with you, you can start up the Oracle instance. That means you will assign the SGA and the processes will be started, and that state will be called as a no mount state. If you have the control files, then the information in the control file is read, and then that state is called as a mount state. So this is a no mount. And then if you have the data files plus the redo files, then the instance is called to be in the open state. So we will again discuss this thing in much more detail. When you have only the P file, that means if Oracle has read only the information in the P file, we say that the instance is in a no mount state. Why we are starting up the instance in no mount state? Because there is no control file, because there are no redo files. The only file that we have is the P file, and that is why we are forced to start the instance in a no mount mode. These are the phases: no mount, mount and open. So we have started up the instance in a no mount phase. The instance knows what are the important parameters, and those are read from this file. Now the next thing is to create the database. So now you are inside SQL Plus. At this time, if you go to another session, if you go to another window after you start up the command, you type the command ps-ef, you will see those processes. Which process? LGWR, DBWR, PMON, SMON. Those processes will be displayed as Unix processes. At the same time, if you fire the command free, then you will suddenly realize that the amount of memory has been reduced by that SGA, or somewhere close to that. So earlier it was 800 megabytes were free. Now I have started up my instance. Suddenly my free memory has now gone down. Why? Because SGA has been allocated. So that is something that you can check in the another window on the same machine though, on the Unix prompt. Now the instance is started. It is in a no mount phase, and now we are going to execute a command called as create database focus 1. Create database focus 1. Okay, and then we are going to say max. There are quite a few max parameters. Max data files, let us say 100. I'm going to say 100. What am I saying here? That I'm going to create a database whose name is focus1, and this database will have maximum of 100 data files and not more than that. So when the database is created, obviously we are going to have at least 4 data files, one for system, one for sysocs, one for temp and undo. We are going to create additional ones, and we cannot grow beyond 100. That is the limit I am putting. And if you don't want to put the limit there, there is obviously a limit of 32,000 something. If your database is going to grow bigger and bigger in number of files, then keep the higher limit, because this cannot be changed later. This cannot be changed later. It can be changed, but there is a very tricky and cumbersome process for that. So this is the max data file. Similarly, max log files. Max log files, let us say we say 10. So the total number of redo log files. Total number of redo log files is going to be 10. So likewise, there are quite a few max related parameters. I have just mentioned 2 of them, and this cannot be changed very easily. So now create database focus 1, all these things are there, and then you are going to specify data file, and the name of the data file you are going to say somewhere u01 app blah 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 system.dbf, system.dbf, and then you are going to specify after that size is equal to, let us say, 400 MB. So what is happening? You are instructing this create database command that please create a system table space, and the file inside that system table space will be system.dbf and the size would be 400 megabytes. You are instructing that. Then you are going to talk about the log files. System table space is created. Then we need to do sysocs, right?
Sysocs space data.
Sysocs, then data file. Okay. Sysocs data file, and again you are going to write in single quote there the name of the file u01 blah blah blah. That whole path u01 app oracle ora data, and inside that there would be the focus one, and inside that there would be sysocs. So I will write that full path here at least for once. u01 app oracle, then ora data, ora data slash focus 1 slash sysocs syx. So I'm going to say sysocs1.dbf. And why I'm saying sysocs1.dbf is because let us say this is now 300 megabytes. Because later on, if I want to add one more data file to the sysocs table space, I will call that as sysocs2.dbf. It is good naming convention there. So that's why I can do the same thing over here, system1.dbf, and the next file that I may add a little later, if the size of the system table space has to be increased, at that time I will call it as system2.dbf. So data file, this is, you don't write here system here. This is not written. So you just say data file, and this is the system table space sysocs, and sysocs' data file is here. And now we have other two things which are temporary and undo. So I will now write somewhere here, but this command is still going on. It's one and the same command. It may come on 4 or 5 different lines. So I will write it here again. So we will write undo table space, and again the file u01 undo one. No. Undo table space. What was the name of the undo table space that we had given? No, it was UTS1. That was written inside our file. So that must be written over here. If you by mistake use something else, it will be a problem. So undo table space UTS1. The name of the file is, let us say, maybe UTS1_1.dbf, and the size. Now what should be the size of undo? Again, depending on the transactions, how many deletes are going to happen and all that stuff. Keep the size same in our lab here, not gigabyte, just megabyte. Okay, so this is the undo. The command is still continuing, and now the final is temp. Okay, now then you are going to say default temporary table space. What is going to be the name of the default temporary table space? You can give anything, TMP or TEMP or whatever that name is there. So I will give the name as TEMP, default temporary table space temp, and then you're gonna say temp file. We could have done this thing using the create table space command, create temporary table space command also, but I prefer to do this using the database creation itself. So undo table space can be created as a second step, and temp table space can be created as a third step, but I'm giving it the whole thing in one go here. So you can do it that way also. So default temporary table space temp file, and then the name of the temp file, and then the size. So once this is done, then you are going to just hit semicolon. This is where the command log file we did not do. Oh yeah, we did not do log files at all. Okay, so we have done the 4 data files: system, sysocs, undo and temp. Now we have to create the log files. So the command will again go further. The command is still bigger now. Yeah, I forgot the log file. You are going to say log file. Now log file, the correct word for those log files, we saw first log file and second log file. Actually they don't call it a log file, they call it a log group. The correct wording is a log group. Why they call it a log group? Because we do multiplexing. one file is multiplexed, a copy is done, one file is multiplexed over here, and second file is multiplexed over here. So the first one is called as the first log group, the second one is called as the second log group, there could be a third log group. So in each of those log groups there could be multiple log members. So correct terminology now I will say here, there is a log group and log member. So in our database diagram here, so let us say this is the LGWR process which is writing from this. So first it will write to this one, this is called as log group, let us say group number 1, and this is log group number 2. Why it is called as a group? Because if you do the multiplexing, then it is called as a group. So this will be the first member of log group 1, this will be the second member of log group 1, this will be the first member of log group 2 and second member of log group 2. And if you decide to have one more log group, then again the first member and again the second member of log group 3. So 1, 2, 3, these are the log groups, and 1, 2, 1, 2, 1, 2, these are the log members within that log group. Within that log group. So what we are actually now going to do is use this terminology, log group and log members. So we are going to say log file group, the first group and the second group. At least 2 groups are required, you can give 3 groups also. So within the first you are going to write the names of the members. So the first name is U01 and let us say log 1 dot log or redo, I would say redo, you can give any name, sir. Redo 1 dot log and then comma. If you want to have another member, you give U01 redo, no, I need to give a better name here. I would say redo 1 maybe 1 dot log. So the first group and the first member, and here I will give the name. I am not writing the whole thing because I don't have enough space. I will say redo 1 underscore 2 dot log. What is 1 underscore 2 dot log? The first group, second member. And here I would say the redo 2 underscore 1 dot log, because the second group first member, comma redo 2 underscore 2 dot log. Now is this really required? This is usually not required unless you want to focus on safety. Right now let us not focus too much on safety right now, but yes, these are important files and you should be able to have a safety factor there, that if something goes wrong with this file, I have this file. The contents of these 2 files is exactly the same. When these 2 files, one transaction is written by LGWR, it is written over here as well as it is written over here simultaneously. So group 1, the names of the groups, and then you are going to give size. Size, let us say 10 MB. So both of these files will be 10 MB and 10 MB each. And here also the size. Here also size of this guy, size 10 MB. So this size will be 10 MB, this size will also be 10 MB. And then the semicolon. So this command has just finished now. To understand this command, our whole discussion so far has hopefully helped. That what is a database and all that stuff. So this, at this time, what will happen? When you type this command, first thing that it will do, it will go and create the control files. Which control files? What would be the names of the control files? Whatever we had written inside our init file, the P file. That will be the names of the control files. Those 2 control files will be created. After the control files are created, it will create the system table space. Then it will create the sysocs table space, the data files for that. Then it will create this, the temp and the undo. It will also create these files. So how many files will get created by executing these commands? Redo 4 files. Okay. Then 1 for undo, temp, system and sysocs. So those 4. And then control files, we gave 2 names there. So those 2. So total 10 files will get created after we execute this command. You can go and type ls-l command and see those files and they would be created. So this is our database is created, and one last thing, all this database is blank. There is nothing in the system table space. There are no data dictionary views in the system table space also. Nothing is there. So our first step is to create the data dictionary views now. So after this is done, we create the data dictionary views, and data dictionary views are basically just views, the create table command and create view command and all that stuff. All those things have been kept into one file called as catalog.sql. This is a file that will come with the Oracle software when we install Oracle software. There is another file called as catproc.sql. These two files are very critical. This will create the catalog database, that means the data dictionary views, and this will create the stored procedures and functions which are useful for DBS. All this is developed by database, by Oracle. So how do you execute this thing? You are inside SQL Plus, and you are going to just put an @ sign. You know how to execute an SQL script. @ sign and the name of the file, and the name of the file should be the full name of the file, and the name of the file is going to be and it is inside Oracle's home directory. So we can specify Oracle home RDBMS admin, and then the catalog.sql. Same thing for catproc.sql. Oracle home is the directory where Oracle software is installed. That will be U01 app Oracle product, and so on and so on and so on. So you run this file and you run this file after that, and that time the data dictionary will get created, the stored procedures will get created, and now you have a raw database for you. Just a raw database. Now you can create additional table spaces. Now you can create users and all that stuff. Now you can grant them the roles. After this thing is done, the standard roles which we saw last time, DBA, we saw a connect, all those roles will also get created, and then your database is, as I said, it is raw. So very first thing that you do after this is done is to take a backup of the database. The first time you have created the database, it is raw, it is not there is no actual data, employees or orders. You take a backup of the database. We'll see how to take the backup later. And then, because once you have the backup, then if something goes wrong in the future, you can get it from the backup. You won't have to go through the whole procedure again. So this is how the database is created. So we're going to tomorrow actually create the database. We are not going to do the installation of the Oracle software tomorrow, but we will assume that database, the software is installed, and then we'll do the database creation. That's it.